Hi 7th graders, it's Mrs. Tremblay, and today we're going to learn all about like terms. I know we started learning about this in class with the algebra blocks, and now we're kind of going to take the blocks away and see what the blocks helped us to understand. So what are terms? Parts of an algebraic expression are called terms. And terms are they're separated by addition and subtraction signs, or for us, we'll just look at it as they are separated by addition signs because we keep change all of our subtraction anyhow. So in the expression, negative 10x plus 4x minus 5y plus 1, the terms are. So here's an algebraic expression, right? It says that parts of an algebraic expression separated by addition and subtraction signs are terms. I'm going to change this subtraction to addition right off the bat so we identify the correct sign of the term. Before you identify the terms, you should keep change. So this negative 10x is separated from 4x by an addition sign. And this 4x is separated from negative 5y with an addition sign. And this negative 5y is separated from 1 by an addition sign. That means my terms in this expression are negative 10x, 4x, negative 5y, and 1. So it's as simple as that. You just look at each little piece of the expression that has an addition sign between it. Alright, so what are like terms then? Like terms are terms that have the same exact variable raised to the same exact power. They have the same exponent. And also, if a number doesn't have a letter attached to it, it's called a constant. Constants are also like terms. And you've been adding and subtracting, multiplying and dividing constants for a long time. I don't know that you knew it was called a constant, but basically like a number like 3, that's a constant because it doesn't have a variable attached to it. So the first thing I want you to be able to do is identify like terms and some unlike terms. So I have a little table here to show you some examples and some non-examples. So this first part here, like terms. Negative 2x and 7x, those are like terms because they both have an x. Don't we all? Negative 4y squared and y squared are like terms because, again, they share y squared. And if you have negative 4y squared, and we just see this y squared, you might be thinking, well, how come there's not a number in front of it? Remember, when you just see the variable without a number in front of it, it means you have one of it. So y squared means you have one y squared. And 3 and negative 4, even though those have different signs, they're like terms because they don't have a variable. They're both constants. Some examples of unlike terms would be negative 2x and negative 6y. This has an x, this has a y. The variables need to be identical. Those two would not be like terms, negative 7y and negative 7y squared. And you might think, well, wait, they both have negative 7. It's not about the number. It's about the letter. So here's why. This one has y squared. And I'm sure that we have already talked in class about how like terms are really stuck up and they will only hang out with other terms that look just like them. Well, this y is not going to hang out with this y squared because it has a little 2 on it. I know, they're so mean, aren't they? They're very cliquey. Like terms. So those aren't like terms. And lastly, I have an x and a 5. This 5 doesn't have an x. Not hanging out. This is a constant that has a variable. So hopefully we understand the difference. And what I'd like us to try right now is just to take a look at this expression, 9x minus 2 plus 7 minus x. And I want us to identify the terms and then identify the terms that are like. So first off, I told you up top that before you identify the terms, you want to make all subtraction addition. So I'm going to keep change in the expression. Alright, so all I'm doing is I'm looking at the little pieces of the expression that are separated by addition signs, and those are my terms. So here's 9x, and then this isn't a 2, it's a negative 2. Be careful with that. And then here's an addition sign. We have a 7 and a negative x. Do you have any negative x's? Yeah, I know. Okay, so now what we want to do is from the terms that we have, I want to combine the like terms. And remember, when you see this negative x, it really means that you have negative 1x. So you have one negative x. Everybody does. Like terms share the same exact variable, right? So in looking at this, here's 9x. this doesn't have an x, this doesn't have an x, this does. So 9x and negative 1x are hanging out. Those are like terms. And we're left with a negative 2 and a 7. Now it doesn't matter that this one's negative and this one's positive. What matters is that both of them are constants. Neither of them have a variable attached to it, so that would make negative 2 and 7. Those are also like terms. Do any of you find it strange that I make my 2's different? I know. I've always done that. It's very strange to me. Maybe you didn't, and now from now on you'll be watching and see how often I do it. It's a lot. Anyhow. Alright, so why are we looking for like terms? Well, because your job is going to be to combine them. Because we always want to write everything in simplest form. I'm sure your favorite thing to simplify are fractions, because fractions are everyone's favorite. I know. And so an algebraic expression is in simplest form if it has no like terms and no parentheses. So today we're going to focus on this like terms piece, and the next lesson we'll focus on the parentheses. But basically, this expression all the way up here, that's an algebraic expression, right? This isn't in simplest form because it contains like terms. Negative 10x and 4x are like terms, aren't they? So this would not be simplest form. So it's going to be your job to rewrite these expressions in simplest form by putting the like terms together. And how do you put them together, you say? We do what we've been doing with the blocks all the way along. Hopefully that has helped you to understand what we're about to do now. All you have to do, first off, you already know this rule, change all subtraction to addition by adding the opposite. And if you see a variable that doesn't have a number in front of it, a coefficient that's called, put a 1 in front of it. Okay, so put a 1 in front of any variable that does not have a coefficient. And what's a coefficient? It's just the number that's in front of the letter. For example, in the expression 5x, 5 is the coefficient. So coefficient is shorter than saying number in front of the letter. So for once in math, the key word is shorter. It's nice. All we have to do to combine like terms is add their coefficients. So you just add the number in front of the letter and put them together. That's it. Write the remaining terms after everything's been combined. And please remember that only like terms can be combined. You can't combine anything else because we learned that x's and y's won't go together. The green blocks and the yellow blocks won't go together. So keep that in mind as we're working through. So turn your page and we're going to get to the example page. The fun stuff. I know, these are your favorite part, aren't they? This is where the magic happens, where we learn all about what we have to do. Okay, so the directions say simplify each algebraic expression by combining like terms. And your step 1 is to keep change, right? So change all subtraction to addition. So here I see subtraction. I'm going to add the opposite, and add the opposite. Lots of subtraction going on. All right, once we have done that, we're going to look to see if I have any variables that need a coefficient. And by the looks of this, nope, we don't. They all have coefficients. All right, I'm going to start with the squared terms because you'll learn next year that the highest exponent actually does get to go first in the expression. It doesn't really matter for us today which one you start with, but I'm going to start with the higher exponent. So I see I have a negative 6x squared. It's not a 6x squared. We keep changed it. It's a negative 6x squared. 5x and 7x, negative 7x, aren't going to hang out with a negative 6x squared because that x has a little 2 on it. And those x's are way too stuck up to hang out with anybody that looks different from them. It's so sad. But negative 9x squared will hang out with negative 6x squared because both of them have identical variables. So how do we combine them together to simplify this expression? We add the number in front of the letter, the coefficient. And a negative 6 plus a negative 9 gives us negative 15. And we have negative 15 what? X squared. You don't all of a sudden have x to the 4th because that's a complete different block if you recall from our algebra blocks, right? X squared stays the same. The only numbers that are changing here are the coefficients. All right, now we have a few more like terms, right? 5x and negative 7x share the same variable. Those are like terms. They can be combined. 5x plus negative 7x means all I do is take 5 plus negative 7, and that's negative 2. And I have negative 2x x's. Now, we're adding all of these together, right? I need to put an addition sign between each term. Otherwise, they fight because this x squared will not hang out with that x, and I need this addition sign, or they brawl. From here, you can't combine those. You can't say that you have negative 17x cubed because these are x squareds and those are x's, and you don't have negative 17 of anything. You have two separate blocks left. So at this point, you're done. All set. All right, move on to the next one. I have negative 8xy plus xy minus 10x plus 5y. And I said that your first task is to always keep, change, change. So let's do that. There's subtraction here, so I'm going to keep, change, change. And the next thing I said is if you see an expression that doesn't have a coefficient, you see variable without a coefficient, we need to put a 1 in front of it. And right here, how many xy's do we have? We have 1 xy. And we know that this doesn't mean I have two separate terms. This xy represented that light orange rectangle, right? So negative 8xy is one term. There aren't three terms here because there's not an addition sign between these variables. They're being multiplied. So right now we're dealing with 4 terms. And in order to simplify this, we need to make sure that there are no like terms in the expression. But I can see that there are. I see that here's a negative 8xy, and I have another xy. Now you might be thinking, but this has an x and so does that, and this has a y and so does that. It has to be identical. So if this expression has xy, xy, this needs to have xy, and so does that. So those two are the only ones that will combine. To combine them, I'm going to take a negative 8 plus 1. Because remember, we have 1 xy. So putting that 1 in there will help you not to just bring down a negative 8. It's actually negative 7 xy that you have. And in looking at this, see that negative 10x and 5y, those can't combine. This is an x, this is a y. So if you can't combine them, all you need to do is just rewrite them. And again, please make sure to put the addition signs between each term so they don't fight. I do not want that. Scary times. All right, move on to the next one. Step 1, keep, change, change it. So add the opposite, add the opposite, add the opposite. There's 3 spots you needed to do that, and yes, please do that, because otherwise you're going to think this is a 3y when it actually has a value of a negative 3y. Changing everything to addition also allows us to add these in any order that we want, so it's important. All right, I'm going to start with the highest exponent again, and I see I have 12y squared. That y doesn't have a squared on it, so nope. Negative 8y squared, and negative 4y squared. So those are all y squareds. Those can all be put together so that we can simplify this. And when you take 12 plus negative 8, that's 4. And 4 plus negative 4 is 0. Now I know some of you are tempted to write 0y squared. That's a no-no. What is 0 times y squared? What's 0 times anything? It's 0, right? So you don't need to write that. Right now, we have 0. Let's look at the rest of our expression. I have a negative 3y, and will negative 3y and positive 3y hang out? Yes. They don't know why, but they just will. Well, they know why, because they both share the same exact variable. When you take negative 3 plus positive 3, you get 0. And I know you're going to want to write 0y. What's 0 times y? It's 0. So if your job is to write things in simplest form, don't write 0 times anything. It would just be plain old 0. So if you're left with 0 plus another 0, the answer to this, the simplest form of this, is 0. We did all that work for nothing. Yep. This is a lot simpler than that, right? What's kind of cool is that those actually have the same exact value. This expression right here has the same value as that one. No matter what values we plugged in for y, we would end up getting 0 in the end. So again, I don't want to see 0 as a coefficient. Just write the 0, no letter attached. And don't write 0 plus 0 because we know it's 0. All right, moving on. I needed you to see that there are decimals, and decimals are okay. You solve these the same exact way. So step 1 is to keep, change, change any subtraction that you see. It looks like it happens twice. And then we're going to put all the like terms together. So here I see I have a 3a, that doesn't have an a, this does have an a, and that doesn't. We'll add the coefficients for the a's. 3 plus negative 4.5 means I subtract and take the sign of the greater digit. So that leaves me with negative 1.5a. And then we have 7.9 and negative 5.3. Those are both constants, right? So we can add constants together. And I know that when my signs are different, I subtract the digits and take the sign of the greater digit. So when you subtract the digits, you get 2.6, and the higher digit is positive, so that's it. Negative 1.5a plus 2.6. All right, next, we have 4x plus 4y. There's no keep, change necessary. I don't have any missing coefficients. I just need to combine like terms. I see they both have a 4, but this is an x and this is a y. Can we do anything to that? Nope. So I'm not going to leave this blank. If you leave it blank, I might think that you don't know what the answer is. You have two options. You can rewrite it, because if your object is to simplify it, that's simplest form. Or you can just write, if you wanted to, cannot be simplified. One or the other, or both if you want. Overachiever, you like to write, I like to write. You can write them both. Anyhow, there's nothing that we can do there. And this was just to show you that matching coefficients don't matter. It needs to be matching variables. All right, last one. I saved the best one for last, the one with the fractions in it. Yay! I know, it's 3/4 and 1/2 though. So looking at that, coming up with a common denominator should be a piece of cake for you by now. We had a whole chapter on this. Step 1, let's keep, change it. So this was minus 1/2. This is going to become plus negative 1/2. I'm putting the negative sign with the numerator. And subtracting 6 is going to become plus negative 6. So our step 1, let's combine our y's together. So we have a 3/4 plus a negative 1/2. I need a common denominator. I'm thinking that common denominator is probably 4, right? So this 3/4 gets to stay the same, and I'm going to add to that. When you change negative 1/2 into fourths, negative 1 times 2 is negative 2, and 2 times 2 is 4. Add the top, so 3 plus negative 2, that gives me a positive 1. Bring over the denominator. So 3/4 plus negative 1/2 is going to give me 1/4, and don't forget the y. You have 1/4 y. And we also have this 12 and this negative 6. Those are both constants. We can combine them. 12 plus negative 6 is 6. And we have simplified the expression. It was not too bad. Now we're done. I'll see you tomorrow.